Hello friends, this video on solutions part 1 is brought to you by examfear.com. No more fear from exam. The objective of the lesson is to describe the formation of different types of solutions. We'll also express the concentration of solutions in different units. We'll explain Henry's law and Rawls' law, very important law. We'll distinguish between ideal and non-ideal solutions. We'll also explain the deviation of real solutions from Rawls' law. And we'll describe the colligative properties of solutions. We'll also discuss the abnormal colligative properties exhibited by some solutions. Let's start with this chapter, solutions. So you see, almost all the process in the body occurs in some kind of liquid solution. Please note, almost all the process that happens in our body happens in some kind of liquid solution. If we talk about digestion of food, so digestion of food, you need HCl. That's again a solution. If you think of the blood in the body, blood is nothing but solution. If you talk about the whole nervous system, right? Nervous system runs on chemicals. You must have heard about it. And these nervous system runs on chemicals. And these chemicals are nothing but solutions. The medicines which we take is nothing but solution of different solutes. So, in fact, the air we inhale is a solution. The air we inhale is a solution. So, solution has a very critical role in our life, right? For our existence, solution is mandatory. The air we take is a solution. Most of the fruits, most of the food we take is solution. And the whole body is solution. Actually, the blood is solution. The whole digestive system runs on solution. The nervous system runs on solutions. So, solution has a very important role in our life, right? So, let's see the definition of solution. See, solutions are homogeneous mixtures. Please note, they are homogeneous mixture. Homogeneous is different from heterogeneous, correct? You know that? So, if you see, if a compound or if a solution is homogeneous, and the moment I say homogeneous, I mean that the composition and properties are uniform. For example, this is a homogeneous mixture. So you take some water, put some salt or put some orange juice, you mix it well, that becomes homogeneous. That means if I take a small amount of solution from here or from here or from here, it will have same properties. That is homogeneous. The opposite of this is heterogeneous. See, in case of heterogeneous, the components are not uniform. For example, if I take some amount of mixture from here, I may get one badam and some bhujiyas. If I take the same amount of mixture from here, I may not get badam, I'll get some different thing. If I take it from this area, may get 3 badam. So, if you see, if you take from this area, it will be all different. So, heterogeneous is something where the composition and properties are not uniform throughout the mixture, right? So, for example, in this case, if I take small amount, the same amount from here and same amount from here and same amount from here, the properties and the composition of the substance which I'll get is different, correct? So, that is the difference between homogeneous and heterogeneous. So, solution is what? Solution is nothing but a homogeneous mixture of 2 or more than 2 compounds. We'll see more definitions of solutions in the next few slides. This was just to explain you also the difference between homogeneous and heterogeneous. Let's see the solution in our daily life. So we see in normal life, we rarely come across pure substance. Pure substance is something which is very rare in our life, very rare. Mostly we use solution. Solution is prominent, correct? I'll show you some examples of solutions and you'll be surprised to see that we really use them in our life. For example, brass, German silver, bronze, all these are nothing but solutions. You must be thinking solution is something which has to be liquid. That is not true. Solution is nothing but a homogeneous mixture. Correct? So let me read once again. It is nothing but homogeneous mixture. So it can be liquid, it can be solid, it can be anything. So if you see the brass, it has copper and zinc. If we talk about German silver, it has copper, zinc and nickel. If we talk about bronze, it has copper and tin. So if you see, these are my solutions actually. Brass is a solution of copper and zinc. If you take small amount of brass from here, small amount of brass from here, the composition will be all same. If you take small amount of bronze from here, small amount of bronze from here, the composition will be same. The next good example we have is of the Coca-Cola or any cold drink we drink, right? The drinks which the packaged drink. If you see, if you take a small amount of drink from here or a small amount of drink from this side, right? It will have same composition. The bleaching powder which we use, that is also a solution, right? We take small amount from here, small amount of here, they'll have same composition, provided you shake it well, right? If you shake it well, you'll get the same composition. Fluoride generally we use fluoride in water. So, and this is very important in our life. For example, this bleach is used to clean clothes. Similarly, fluoride has a huge importance. If you have 1 part per million of fluoride in water, it will prevent the tooth decay. And if you have more concentration, maybe 1.5 part per million, it will make your tooth mottled. And higher concentration of fluoride is poisons also. If you see, the sodium fluoride is used as right person. So that's a different story altogether. But what I'm trying to say is that fluoride ion is used in our day-to-day life. It is generally mixed in a very small quantity, 1 part per million in water, and it helps tooth decay, right? And this drinks we use, this orange juice or any lemon juice, any juice we take is nothing but a solution. Why solution? Take something from here, it will be of same concentration. The paints which we use is also a solution to paint the house. Correct? This all apple juice or any packet juice is also solution, provided you shake it well. The tea and the coffee we drink is also solution. Why? Because you take some tea from here, some amount of tea from here, some amount of tea from here, you'll see that composition of tea is all same. The air we breathe, the fresh air we breathe here, right, is the best example of solution. It has carbon dioxide, nitrogen, oxygen, a lot of stuff. It's a solution. You take some amount of air from here, some amount of air from here, it will have same composition. Almost. But if you take from 2 different cities, the composition may vary. If you take from a village and you take from a polluted city, the composition of air may vary. What I'm saying is, in the same city you take from here and from here, just nearby distance, you'll get similar composition, and that is why air is also solution. The normal water which we drink is a example of solution. Even the gold jewelry we wear is solution, because most of the gold jewelry you see is 22 karat or 18 karat or 20 karat, right? So these are my solution, because we don't use pure gold. We mix it with some impurity so that you make the gold more harder, right? So this is all are my solution. So you think of gold jewelry, you think of solution. So let's go ahead and understand the solution in more detail. To understand the solution in more detail, you should know these 2 terms, solvent and solute. So let's see what they are. See, solvent is the component that is present in large quantity. So if you see, if you take water beaker, fill it with water, that is in large quantity, and you add some 2-3 drops of, let's suppose, iodine or any liquid, 2-3 drops of any color, the solution, what you get is solution, and the color is different. So you have something called solvent, I have something called solute, I will get solution. So I have solvent. When you add solute to a solvent, you get solution. Correct? So let me define these now. See, what is solute? What is solvent? So if we talk about solvent, let me start with solvent. Solvent is the one that is generally present in large quantity. Present in large quantity. Right? So if I have a solution, it will have something called solute and solvent. And this solvent is came from a Greek word, that is solvo. It's a Greek word solvo, that means free up or mix. So something that free up something, I will talk about that something. That something is solute. The solute is something which is generally present in small quantity. For example, in a beaker of water, you add 2-3 drops of color. So color is my solute here, and water is my solvent. And generally there is only one solvent, because that is something which is present in large quantity, and that is something which frees up other thing. And then we have solute. Solute also came from a Greek word, or in fact Latin word. Both came from Latin word actually. Latin word, that is solutus, right? And solutus means to loosen. But that means something that loosen its identity is solute. Because solute is the one, you see here, I'm adding 3 drops of water. That 3 drops of water is losing its identity. Or if you add 3 or 5 pinch of sugar in this, or salt in this water, that sugar or salt will lose its identity. It will mix in this solvent. So something that loosen its identity, right, is my solute, and something which is in the bigger quantity and something which helps solute to lose its identity is solvent. So generally you have only one solvent, but you can have more than one solute. For example, if I take a glass of water, in this I add salt, in this maybe 5-6 pinches of salt, in this let me add 2-3 pinches of sugar, let me also add here 2 drops of some iodine. So once everything is mixed, if you see, you won't be able to see sugar, you won't be able to see salt, you won't be able to see iodine. Those things are lost. They lost their identity, right? What you see is only the liquid, and that liquid predominantly came from this solvent, and what you get is solution. So you have something called solvent, you add solute to it, you get solution. So this is in the small quantity, less quantity generally, and this solvent is in the large quantity. Correct? So mostly it is like that. That is not 100% true definition for solute and solvent. They are universal solvent like water, benzene, toluene. They generally use because they are the one they mix. I mean, a lot of other compounds or components, they mix well with these components. Correct? So with this we can redefine solvent as, solvent is nothing but a substance. Solvent is nothing but a substance that dissolves solute to form solution. Solvent dissolves solute to form solution. Similarly, solute is nothing but a substance that is dissolved in solvent to form solution. So end of the day, the final product is solution. That is nothing but my homogeneous mixture. Correct? This is my homogeneous mixture. So this homogeneous mixture is my solution. So to get this solution, you need something called solvent and solute. You'll have only one solvent and you can have more than one solutes. Correct? So this is something which is large quantity, and this is something in the less quantity generally. In I'll say 99% of scenario. Correct? And general, for example, a solvent is water, benzene, toluene. An example of solute is sodium chloride or sugar, those kind of things. Correct? And please note here, since solvent is in large quantity, this determines physical state of solution. If solution. Correct? We'll take more examples on this. Here we had this water as solvent and water as liquid, and thus the solution which we got is liquid. If you take gas as solvent, for example in carbon dioxide gas, you mix small amount of oxygen. So carbon dioxide is a gas, there is my solvent there, so the solution also you will get in gas. Or you take gold as the solvent, in that you add some impurity, that is my solute, you get 22 karat gold, that is my solution, and that is also solid because my solvent was solid. Let's understand this. Let me take 24 karat gold, add some copper, small amount, and you get 22 karat, sorry, let's suppose 20 karat gold. So here my 24 karat gold is a pure gold, that is my solvent. My small amount of copper or impurity that I'm adding is my solute, and what I'm getting is 20 karat gold, that is my solution. So in this case, if you see the physical appearance of my solution, that is my 20 karat gold, will be similar to my 24 karat gold, that is my solvent. So this was my solid, this is also my solid. Correct? So generally it is the solvent that determines the physical property of solution. Solute is always in a small quantity and doesn't play much role in the physical state of the solution. Correct? So once again, solvent is a substance that dissolves solute, and this solute generally lose identity. Correct? Solute is a substance that is dissolved in solvent to create solution. The example which I told, you take a glass of water, this is my solvent, add some sugar crystals, that is my solute, you will get a solution. And if you see, the solution will also be a liquid. Why? Because the solvent was liquid. Another example is, you can take this water, sugar, lot of sugar, add only 2 drops of color, 2 drops of color. So in this case, and let's suppose you are taking 500 gram of sugar. So in this case, I'll call sugar as my solvent because that is in large quantity and it's 500 gram and this is only 2 drops. Right? So in that case, I'll call this guy as a solvent, and this is my solute. So it is not that solute has to be liquid or solvent has to be solid. Solute and solvent can have any physical state. We'll show you some other examples where we'll show you different permutation combination of solid and solvent. Correct? So in this case, this is my solvent, and what the solution which will be get is will have physical property almost similar to this sugar, because as I told, the solution inherits the physical property from, or physical state, not property, physical state from solution. Thank you. Visit examfear.com to watch more videos attempt free online tests, get free study materials, find tutors and mentors, and much more. Thanks once again.